Hey guys, so I've been playing a lot of old PlayStation games recently. Obviously, right now it's Halloween, so I'm playing Silent Hill, of course, um, mainly to study carefully how games were made back in the day with regards to character, level, and gameplay design, but especially lighting. The old PlayStation did not support actual lighting the way modern engines do, and instead, developers would sometimes bake lighting directly into textures or use vector color trickery. This is especially apparent with the flashlight in Silent Hill. If you look carefully, you can see the colors getting brighter along the vertices around the light as a way to fake dynamic lighting. This was very clever back then, but nowadays we have actual dynamic lighting and global illumination and all the fancy stuff, so there's no need to do that anymore. However, since the idea here is to replicate what the PS1 graphics look like, I do need vertex based lighting. Now, I'm not sure if Unreal Engine supports it. I think Unity does, but I know for sure that Godot doesn't. Although it is in development, I've seen the branch on their GitHub, but I don't think it's going to be integrated in a release for a while. So I could have waited, but I still wanted to give it a try. So I came up with this incredibly inefficient way of achieving a fake vertex point light by using a raycast that scans around a point like a sphere with a resolution of 10 degrees up to the distance set by the point light radius and collects the meshes it hits as well as the collision points. The collision points, as well as the light parameters, are then passed to each affected shader. The shader then checks each vertex in world space against the list of collision points to see if a light ray hit close to it, and if so, the light parameters and the distance of the vertex to the light source are used to calculate the final lighting color. The perceived brightness of the lit color and the original color are then compared to prevent negative lights, and then the final lit or unlit color is set as the vertex color. This is done on every physics stick for dynamic lights or only once for static lights. Originally, I came up with a solution that used a simple collision sphere, but then I couldn't account for objects occluding the vertices from the light, so I started over and came up with a raycast solution. So yeah, I'm pretty sure the actual engine vertex lighting will be much more efficient, but hey, it's all a fun learning experiment. As you can see here, I can change the light parameters in real time, like the color. I can change the radius. I can change the light intensity, the fall off, and check whether the light is dynamic or static. As you can see, it stopped calculating it. So yeah, that's it. Subscribe if you want to keep track of my progress and see more of my little experiments, and I'll see you later.